Okay, let's continue. So we have seen this way of solving trigonometry equations with multiple angles. So there are multiple set of solutions in this case. So typically more than two. After that, you can just disregard this part using trigonometric identities to solve equations. This is more advanced way of solving equations. We're not going to deal with this part. Just skip this. So that's it for trigonometry equations. One more thing is we haven't talked about the tangent equations yet. So for tangent equations, the method is a little bit different, but it's actually quite easier than sine or cosine equations. So for tangent equations, go here to the YouTube lectures and watch this video, this tangent equation solutions. So this video explains the equation quite nicely and easily. Okay, so we'll go back here to the slides and we'll talk about the law of sines. So here, this is the law of sines, a new type of formulas. And there are two types, both are similar. And the equations are quite symmetric, so it's not too difficult to memorize these formulas. But I will also provide the formulas to you when you take the final exam. So the equation says, when you have a triangle, three angles, A, capital B, capital C, and three sides, A, B, and C, notice the position of the capital letters and small letters. They are on the opposite side. The angle A is here, go across the triangle, and this is side length A, okay? And angle B is here, go across the triangle, and this side is the side length B. So the relation between the angles and the lengths of three sides are written, nicely written here as a formula. So A over sine A equals B over sine B equals C over sine C. Taking the reciprocals of the three quantities, we get the second type of formula, sine A over A, sine B over B, sine C over C. They are all equal to each other. So we'll use the first type of formula when you want to figure out the side length, A, B, or C. We use the second formula when you want to figure out the angle values, angle A, angle B, angle C. So use the unknown values on the top of the fractions. So unknown values go to the numerators of the fractions. So here's a question, example. A typical example. So if you're given a triangle and a few angle values and side lengths. Okay, so what we need to figure out is two more sides and one more angle. Okay, and the sum of three angles of a triangle equals 180 degrees all the time, right? We'll use this property to figure out the third angle when you're given two angles. Whenever you know two angles, the third angle comes from this formula here. So 1 of 1 plus 55 equals 156, right? So 180, 156, the difference is 24 degrees, right? 24 degrees. So this sensor right here is wrong. Sorry about that. We'll work this out again. So B is 24 degrees. Okay. And then we have to find the length A and length C. So let's do A first. So we set up a formula for A. We begin with A, make a fraction. The sign of the angle goes below. We'll compare this with another pair. And we know that this 7.2 and 24 degrees, this is a complete pair, right? Two numbers are all known. So we'll use that pair. So 7.2 is the length. It goes to the top. 24, that's the degree, the angle. The sine of that angle goes down here. And then we multiply both sides. 1 second. A, we also know the angle A, right? Angle A is 55 degrees. Okay. So next step is to multiply both sides of this equation by sine of 55. Sine 55. And cancel this out. So just leave A only on the left. So the result is that A equals 7.2 times sine 55 over the denominator sine 24 degrees. So we use a calculator to compute this fraction. Okay, let's do it here. Use a calculator. So 7.2 times sine 55 equals 0.8191. So write it down. That's 0.81915. Let's use one more digit. And in the denominator, we have to write down sine 24 degrees. So sine 24 degrees. 0.4067. 3. Let's add one more digit. Then divide the numbers. Or we could just do this in one step using a calculator. Just type in all the numbers in the numerator first. Do it over. 7.2 times sine 55. And divide. Oh, I didn't multiply 7.2, sorry. Let's scratch that. This is 7.2 multiplied by sine value. So if you do that, I get this number here on the calculator. And I divide this by sine of 24 degrees. Gives you 14.5. So it should give you 14.5. So the answer 14.5. This is the length of the side A, 14.5. Okay. And we can do the same thing to figure out the value of C. So I fix the slides and write down the correct answers and upload this again. Okay. Any questions? Okay, let's move on. So this is the same for all other types of questions in this section. There are a couple more problems. You can also make a table to arrange the numbers nicely. So we'll do this in the next type of questions. If you go to this ambiguous case, sometimes you may have two answers. And let me show you this example here, where you have two solutions. So a few numbers are given here. The problem here is when you're given just one angle. If you're given just one angle, it's possible that you have multiple solutions, two solutions, or just one solution. It depends. Or you could have no solutions. It all depends on the question. So I'll show you two solution case. So if you're just given one angle, you begin with two tables, right? We write three angles, A, B, C, and three sides, A, B, C, and fill out the tables with the given values, 45 degrees, 5 and 6. There the numbers are. And the first thing is to figure out the second angle, all right? So we'll try to find the angle B because we know the side B. So we'll use this complete pair of A's and use this pair with the pair of B's to set up equations like this. Because we want to find the angle B, B goes to the numerator. So we'll start with sine of the angle B over the side value, 6. And compare this with the pair A. The sine of the angle 45 over the side value 5. And then just get rid of the denominator. And we have sine B equals 6 times, 6 goes to the numerator, right? 6 sine 45 degrees over 5. And compute the number, we get these decimal values. So as a result, what we have is this sine equation, right? Sine of an unknown angle equals the sine value. And I just explained how to solve this sine equation, right? For this sine sections, 7.1, the law of sines, it is typical that you get two solutions in the first quadrant and the second quadrant. So the two solutions are just the inverse sine value, whatever number that you're given here, just take the inverse sine value. And the second solution is 180 degrees minus this angle value here. So these are typical two solutions. So when you take the sine inverse value, you get the first solution. So 58.1, that's one. For the second solution, you do 180 minus that angle. So if you do 180 minus that, you get the second solution. So two solutions are obtained using the inverse sine and 180 minus that angle. That's how you get two solutions. So 58.1 goes to one of the tables. So 58.1. And the second angle, 121.9, goes here. So that's how basically how you get two solutions. The rest is the same as the other example I showed before. So get the third angle. So 45, 58.1, you have two angles. The third angle is, you do 180. So A, B, C, they add up to 180. So these two add up to 45 plus 58.1. Together they make 103.1, right? Subtract, take the difference between this and 180, you get the third angle C. That's going to be 76.9 degrees. Okay. Get the angle C, just use the method we have seen before. Make an equation. So C over the angle sine 76.9 degrees equals, compare this with, say, A's, 5 over sine of the angle, sine 45. Solve this equation. Basically, you're moving this part to the opposite side on the top. 5 sine of 76.9 degrees over sine of 45. Use your calculator, get the value. You should get this number right here, 6.9. So 6.9 now goes finally in there to complete the first solution. And do the second table similarly. You get this number, 1.6. Now this is how you get the two solutions. Any questions? So this second part is typical when you have two solutions like that. And sometimes you may have just one solution. And there are many reasons you should have just one solution. The reason why you can't have two solutions here is that after you get this second angle, see 142.7, the first angle 45, you notice that the sum of these two angles is more than 180. It can't happen, right? If you get into this problem, negative angles or the sum of two angles go over 180, that's when you can't have this second solution. This does not make sense. If it is something that does not make sense, you can say that there is no second solution. Let's look at the third case where you can't have any solutions. In the process, sometimes if you get the kind of contradiction like sine b equals this number, this is greater than 1. And if you try to get an angle out of this number using a calculator, 1.41, let's go here, the calculator. So you see 1.4142. Try to get an angle out of this number. So this is sine equation. So try to take this inverse sine value of this number. See what happens? Not a number. No angle, okay? So that's when you know there is no angle. So no angle means no solution. No solution for this equation. So there's no first solution. If you don't have first solution, there's no second solution either. So this is the case when you have no solution. So if you have some kind of problem during the process of solving the triangles, you'll see when you have one solution, two solutions, or no solution. So that's it for the section on the law of sines. The law of sines are basically used to solve a triangle. Solving a triangle means figuring out angle values, all three angle values, and all three length values. That's solving a triangle. And to do that, we use this law of sines. Okay, any questions? Okay, so this week, there are quite a few advanced topics of trigonometry. So you may have to spend a little bit more time on these. So I'll try to work them out a little earlier than usual. And if you have any questions, contact me, send me an email, or request a Zoom meeting if you need. Okay. So I finished the meeting. I fixed a few slides here. Okay. Okay, the meeting will end here. Okay, have a good day. Goodbye.